then I guess we can get started with our next electrical group. We have the multi-source data collection for sleep disorder study. So, all you guys.
Thank you all for coming this afternoon. We are Team 11E Sleep. We are doing multi-source data collection for sleep disorder studies. Our faculty advisors are Professor Sheikh and Dr. Xiaomu in the back. And we had an industry advisor, Dr. Robert Samuel, who also happened to be one of our sponsors, along with his employer, the Aetna Foundation. Our senior project coordinator is Professor Victor Marcus. A brief introduction as to why our study is important and why we care about it. There's approximately over 70 million people affected by some form of sleep disorder in the United States, in America. They could range anything from bruxism to sleep apnea. And whenever someone's diagnosed with a sleep disorder, they're sent to be observed for at least one night or maybe multiple nights in a sleep center. These sleep centers can be quite costly if you can find one in your area, ranging upwards of $3,000 a night. So insurance companies or medical providers are hesitant to have extended stays. And once you are at the sleep center, you are not only in an unfamiliar environment that's not your bed where you're not going to sleep well and normally as usual, but most of the leads they use there could be somewhat inhibitive to someone who might move at night or roll over. So we had some goals for our project here, and we wanted to design a device that could simulate and take all the same data that you would get from having spent a night at a real sleep center into a portable device that you could take home with you for a night and then take back to a doctor later to be analyzed or have it uploaded. The device should be, we had 5 goals: cost effective, it should be portable so you can take home, it should be reliable so you get good data, it should be secure because this is health data, you don't want anybody getting into it, and it should be fairly easy to use so anybody can take home, turn on, turn off, and use. We started with some research, seeing as none of us had real experience with sleep disorder studies, and we got in contact with sort of an expert, an industry expert in sleep disorder studies, Dr. Michael Grandner, and we had a Skype conversation with him in which he recommended to us some standpoints for our device. Environmental data collection was something that had never been explored before. When you go to a sleep center, they ask you if the room is too hot, too cold, but they don't really note the temperature or the humidity or anything at your house that could be causing these problems throughout the night. He said that the ideal device would last anywhere from 10 days to 2 weeks to collect data for a good study. If you could take it home with you, it wouldn't be as expensive, so you'd have lengthier studies. Wireless would be a big deal, so you didn't have those inhibitive leads that I had mentioned previously. And a readout for that would be easy for medical professionals to view was a very strong point that he and Sleep Apnea Solutions, Dr. Tom, met with us and expressed too. Our electronic research told us that we wanted a smallest that we could get microprocessor to collect data, analyze, send, and or store data. So if you have something on your body that you're sleeping with, it's not as inhibitive and you don't really feel it. And the last part of our research was we took a visit to a real sleep center in King of Prussia. It's called Sleep Apnea Solutions, where we met Dr. Tom. He showed us the leads and a device that you'd be hooked up to if you actually spent a night at his sleep center. As you can see, all these wires would be pretty inhibited to somebody who might roll around or move at night. So this is one of the biggest challenges that we wanted to eliminate with the wireless. And I'll turn it over to Vince to explain how we wanted to overcome that with some of our hardware.
Okay, thank you, Dan. We concluded our electronic research by deciding to go with the Arduino hardware. Reason being because it's an open source prototype platform, meaning that the design specs are easily accessible. You can go to the company's website and obtain the information to design the board if you choose to, but we decided to go with the package. It has worldwide support, and it's based on the Aetna microcontrollers, which is very reliable. In conjunction with this hardware, we went with the XP RF model to answer one of our goals in terms of reliability. This model basically has a very reliable communication between microcontrollers, computers, and anything that we choose to put in our network. It has a low package error rate, low power consumption, which is really good to address our power issues, and also it's supported by the IEEE prototype. Now with the Lilypad, this is also an answer to the portability for the patient, because with this device, you can literally stitch it or sew it onto patients' clothing. Therefore, they can stay in their room if they choose to, or go to another section of their home and conduct this data study. Now, accompanying these hardwares, we chose our sensors. For the on-body, we chose the thermistor. to collect on-body temperature, as well as our environmental sensors, which is another thermistor to collect environmental temperature changes, and our photocell to conduct ambient light sensitivity changes. Now here's a system overview. As I said before, our Lilypad is right here. It collects data information from our on-body sensors. It in turn takes the information and transmits it to the Lilypad XP. The Lilypad XP takes this information and transmits it wirelessly to the Arduino Uno, which in turn collects data from our environmental sensors, as well as compiling all of this information and streaming this data to a computer that is loaded with the software that can present to the patient, the doctors, and anyone who's affiliated with the project what the results look like. And also in the red box right here, the Wi-Fi technology that we will be implementing as a future work. We will discuss this further in the presentation. Now here is our setup during our testing phase. As you can see, right here is our Lilypad. Embedded on top is the XP RF module. Next to it, we have the thermistor, the on-body that's collecting data from our bodies. It's connected, streaming the data to the Lilypad. As you can see right here, our breadboard has attached to it our photocell sensors and the thermistors from our environmental data. It's streaming to our Arduino Uno, which has the software compiling everything. And as you can see, our USB connection is collecting everything, directing it to the computer that has the software so that the patient can use it. And as you can see, it's also powered by the AAA batteries that we will also talk about earlier. And now I'll hand over to Elvin, who will talk about the algorithm for the software for our project.
Thanks, Vince. So the software stage of this program is broken up into two stages, like Vince said. The Uno is connected to a USB computer through a USB cable, and we wrote a program in Java, like as you can see here, where the end user puts in the time they're going to sleep, and then they put what type of sensor it's going to collect data, and you hit run. The program will start collecting data and write all that data with the time taken to a CSV file, as you can see inside the other screenshot. Originally, we chose Python, but we moved to Java due to its syntax and structure. And the second stage of the program is taking all that data that was collected, and what do we do with it? We have to process it for the medical professional. That way they can diagnose and prescribe a treatment. We wrote that program in MATLAB that will take all that sensor data, synchronize it, and plot it in an easy-to-use GUI, which is right here. As you can see here, for the medical professional, all they do is they import the CSV file, import the file with all the raw data, and then you check off the boxes of what type of data that is. The program automatically takes that data, synchronizes it, and plots it. As you can see here, we have on the top room temperature versus time, and on the bottom we have photocell, which is ambient light versus time, and they're all synchronized in the same time, so you can see what value at a certain time multiple sensors at. Now I'll pass it on to Mike, who will discuss testing and evaluation.
Thanks, Elvin. As far as testing and evaluation goes, we were able to successfully implement our two environmental sensors, the thermistor, which would measure ambient room temperature, and the photocell, which measures light intensity. And we have them hardwired so the user can take it home, plug it in the computer, put it in the corner of the room, and then it will collect environmental data as they sleep. For the on-body temperature, we were able to successfully implement the thermistor, and we recently got that working wirelessly. However, that did present many challenges. We had to continually debug our coding and troubleshoot and continually reevaluate our design. And for that reason, we were looking into the XP Series 2s. We feel like those are more modern, they're more up-to-date, and hopefully more user-friendly so we can easily implement the wireless communications. And a little bit about our future work. We were thinking about enclosing the Arduino circuit board into a plastic case, so it's more, instead of carrying around a microcontroller, it's very exposed. We want to have an enclosure so it's safer to use, or safer to carry around, and much easier to use. We also want to develop a Zigbee mesh network, which the Series 2 XPs would help with. It's where we would have multiple XPs talking to each other simultaneously, rather than what we have going right now, which is just one XP communicating with another, transmitting data. And another development we can have is to add more sensors. One of the big pieces of information that sleep centers look into is rapid eye movement, or REM. So we want to incorporate a REM sensor, which would go a long way in helping medical professionals diagnose these sleep disorders. And other sensors we can also use would be heart rate or blood pressure. We want to also develop a system monitoring utility. This would be on the device and alert the user whether or not the system is operating properly. And finally, one of the big things we want to incorporate was also Wi-Fi integration. This red chip up here is called a Wi-Fi shield. It allows the Arduino chip to send the data to a local Wi-Fi network and actually create a separate web page where it would store the data and actually act as a separate database. And we'd also like to incorporate that as part of our future work. So I'll hand over to Faisal, and he'll talk about how we manage our time and money.
All right, thank you, Mike. As you can see here, our project schedule is in the blue bar, and the actual timeline of events is in the red talking bar. We were ahead of the schedule during the beginning process of research, the development, and procurement, finishing all three activities ahead of time. However, during the construction phase, we had a problem with the implementation of the wireless communication between XPs. This is delay, as you can see, testing and evaluation. The good news is that we did fix the wireless problem, and the XPs are sending a good data. For all reports will be done on time. For our budget, as you can see here, we received $500 from Wireless School of Engineering, $500 from Dr. Abu Samuel, also $500 from Aetna Foundation. The total became $1,500. We spent $795 on procurement and busing. We saved $600 for asthma companies, and the remaining total of our budget is $105. So I'm going to hand it back to them for conclusion.
So a brief summary of our project. We started with the original design. We knew we wanted to use Arduino open source hardware due to their usability factor. We had XP Series 1 modules that we thought were great for their low power consumption and point-to-point contact, which was a great starting point for us. And as Elvin had mentioned, originally we were going to use Python to encode our data. However, during the testing and evaluation period, Python did not have the usability that we were looking for, so Java was employed to sync all our data. While the environmental sensors were all perfect, they were employed exactly as we designed. The on-body sensors worked just as we thought they would hardwired. However, as stated multiple times, when it came to employing the wireless from XB to XB, we ran into some pretty significant challenges that led us to make some enhancements. We used Java, as I stated, and the XB Series 2 modules were selected. The Zigbee protocol they use for their mesh networking is a bit more user-friendly to get a multi-sensor array going. You can have talk back and forth. However, by the time we got everything approved to buy them, they were out of stock everywhere. Apparently, they're pretty high commodity. And we found that even though we had set back, in the end, the XBs did work for us very recently, but they still work. And our 5 goals that we initially set out to be cost-effective, portable, reliable, secure, and easy to use. Once the device is on, it does. As Elvin went over, a few clicks and you can have all your data. We do have some future upcoming events. Tomorrow night, we are also presenting at the 2012 Greater Philadelphia IEEE Awards Banquet and Gala in Center City. And as Faisal had mentioned, we're earning a paper into the ResNet Student Design Competition. It's basically a healthcare device competition, which our paper will be submitted in early May, and if accepted, we will go to the competition in Baltimore in late June and early July. So to sum up, we took leads from a real sleep center that looked pretty intrusive at some points and might inhibit your sleep, and turned it into something that may be able to be sewn into actual clothing. As you can see, this isn't our professional development yet. It's not moved to the mass production yet. But it's still a start. It's a good place we want to be at. Just to thank you, a few people we hadn't mentioned before, especially Mr. Sam George, who helped us with all of our connections soldering, and Mr. Ed for setting up our sleep center visit. At this time, I'd like to open the floor for any questions.
So, do we have any questions? We'll start in the back. Go ahead.
How do you monitor REM sleep?
So your eyes are actually a magnetic dipole. So we can do it the same way that a sleep center does. You can buy any type of blindfold and implement. If you put two magnets on the side, when your eyes start flickering back and forth, the magnetic field is able to change. You can actually have a sensor sensitive enough to pick up the magnetic field change, and that's actually how they do it in a regular sleep center. And it's a device that can be implemented in our design.
Another question? You have a second one?
Yes, a quick follow-up. Do you use any audio signal? Last night I woke up in the middle of the night because of the windstorm. Do you do any audio monitoring?
It's also an option. We really wanted to get one sensor working, the wireless. We knew it was going to be an issue. We didn't foresee it would take up as much time as it had. But once you have one network working with a sensor talking to another, you can add data streams to that fairly on a nice expandable pace. Because once you know how the protocol is set up, you can just redo it over and over. So finally, once that was implemented, we could add noise. We want to add, there's a whole bunch of sensors we would love to have on the set. I mean, as much data you can get as possible, the better.
Over here.
Typically, sleep apnea studies involve use of something called a CPAP machine for airflow. Can any of your devices be used to monitor the air pressure, or perhaps even control the air pressure so that that gets adjusted to the optimal thing, linked up to your oxygen levels, which is the way they do it in the sleep lab?
As far as turning it into a control system for regulating the room, that could definitely be possible. That's a little beyond the scope of what we had wanted to do. However, they do use actually in the sleep center, sleep apnea solutions we went to, they specialize in sleep apnea, as you probably could have guessed. They actually use to monitor like airflow in and out. They just put a thermistor right at your nose and your mouth because the temperature will change as you breathe in and out. So that's also essentially we wanted to add to it with the REM sensor, but since the wireless took so long, we didn't get a chance to implement. We will be following it up more since our paper's not due until May for the ResNet conference, but unfortunately for this presentation, we weren't able to.
A question in the back?
Yes, dietary issues. Taking any IVs on dietary before and after sleep, such as teas and caffeines, and also acid reflux could cause a person to wake up.
So as far as like causes or diagnosis or anything, that was strictly in the meeting with Dr. Tom from sleep apnea that we'd gone over, that we weren't going to get involved in any of the medical side of it, so much as they would ask us for the data, what data they wanted us to collect, and we would try to build a device to get that particular data. So as for guidelines for what you should do prior to the use of this device, we had no control, or we weren't involved with.
Zigbee protocol is ideal for short distance communication. Another advantage that it has is burst communication rather than point by point. Do you think down the line you're going to incorporate a local memory storage to be able to kind of burst the data rather than?
Absolutely. The ideal, or what we actually would love to have, is a hard drive that could literally just keep getting data, a little memory burst the data, store it somewhere, either upload it to a cloud database, or ideally a hard drive you can take home with you, run this thing for 10 days to 2 weeks, you bring it to your doctor's office, he has the software on his computer, he plugs it in, checks a few boxes, runs it, there's all your data for 10 days to 2 weeks or however long. So Zigbee is great for that, and with that short range, we chose the XBs for their low power consumption, but the short range also makes it more secure because the signal won't go too far.
We have time for one more. No other questions? Okay, thank you.